Today we will discuss Structural Design Actions AS/NZS 1170, Introduction to AS 1170.0. AS 1170.0 is the Australian standard for structural design actions. It provides fundamental principles for structural loading. It specifies design philosophies and load combinations for structures and their elements. It is the foundation of the AS 1170 series, which ensures the structural safety, reliability, and serviceability of structures. It covers permanent action, imposed action, wind, snow, earthquake loads, and many other loads. It demonstrates compliance with Part B1 of the Building Code of Australia. Structural design, AS 1170.0 uses two main limit state designs, the ultimate limit state and the serviceability limit state. Ultimate limit state design, ULS. This concept in structural engineering ensures a structure will not collapse or fail under the most critical load combinations during its design life. The reasons a structure or building reaches collapse are loss of equilibrium, excessive plastic deformation, structural instability, and material failure. Serviceability limit state design, SLS. This concept ensures that a structure remains fit for use, functional, and comfortable during normal service conditions. It represents conditions beyond which a structure becomes uncomfortable or inconvenient, undergoes excessive deflection or vibration, cracks, or loses durability or appearance. Ultimate limit state design procedure. Determine the importance level and annual exceedance probability of the structure for snow, wind, and earthquake. Determine the permanent and imposed loads as per AS/NZS 1170.1. Determine the ultimate loads for wind as per AS/NZS 1170.2. Determine the ultimate loads for earthquake for Australia and New Zealand in accordance with AS 1170.4 and NZS 1170.5. Determine the ultimate loads for snow and ice as per AS/NZS 1170.3. Determine the ultimate loads for liquid pressure, groundwater, rainwater ponding, and earth pressure loads as per AS/NZS 1170.1. Determine the applicable combination of actions as per Section 4. Analyze the structure for relevant combinations as per Section 5. Design and detail the structure and determine the design resistance. Serviceability limit state design procedure. Determine the serviceability conditions that must be considered and the serviceability load events and limits for the design situation. Determine the permanent and imposed loads as per AS/NZS 1170.1. Determine the serviceability loads for wind as per AS/NZS 1170.2 and for snow and ice as per AS/NZS 1170.3. Determine the serviceability loads for liquid pressure, groundwater, rainwater ponding, and earth pressure loads. Determine the applicable combination of actions. Analyze the structure, design and detail it, and determine the design resistance. Annual probability of exceedance. A structure shall sustain all actions and environmental impacts likely to occur during its design working life. The annual probability of exceedance is a chance that a specified load or event will be exceeded at least once in any given year. This concept is widely used in structural loading, wind, earthquake, and other designs. For buildings in Australia, refer to the Building Code of Australia. For buildings in New Zealand, it's given in Table 3.3 for ultimate and serviceability limit states. Combination of actions. AS/NZS 1170.0 illustrates how loads are combined for ultimate limit state and serviceability limit state design to achieve a desired level of safety and serviceability. Combination of actions for ultimate limit state. The basic combinations for ultimate limit state in stability and separately in strength are specified in the standard, along with combinations for snow, liquid pressure, rainwater ponding, groundwater, and earth pressure. The combination of action for fire uses long-term and short-term combination factors given in Table 4.1. Combination of actions for serviceability limit state. The combination of actions for serviceability limit state is also specified in the standard. Methods of analysis. AS 1170.0 specifies acceptable methods of structural analysis to determine forces, moments, and deflections for ultimate limit state and serviceability limit state design. Structural modeling shall be based on static or dynamic response, time-dependent or time-independent response, geometrically linear or nonlinear response, and elastic or non-elastic response. Robustness requirements. This ensures that a structure withstands accidental or unforeseen situations without disproportionate collapse. Structures shall have a minimum lateral resistance equivalent to 2.5% of the vertical dead and reduced live loads applied at each level. Connection shall transmit at least 5% of the vertical dead and reduced live loads. All parts of the structure must be tied together, and designs must include clear load paths to the foundations. Confirmation methods. All limit states must comply with the relevant design situations and load cases. This is the final step in the structural design process, ensuring that the design resistance exceeds the calculated design action effects for both ultimate and serviceability limit states. Appendix A, Special Studies. This provides guidance for the specific design of structures when the standard does not provide sufficient information often required for unusual structures or where site-specific data is required. Appendix B, Experimental testing may be carried out for structures where more accurate information or specific design parameters are required, including methods for testing to ensure structural reliability in case of insufficient calculations. Appendix C, Guidelines for Serviceability Limit States. This contains serviceability limit state guidelines for deflection, vibration, and drift of members under loading conditions, generally suitable for importance level 2 buildings. Appendix D, Factors as per AS 1170.0. This provides specific load combinations involving earthquake actions and modifies the general load combinations in Clause 4. It provides the probability factor for earthquake loads, and design category in accordance with AS 1170.4. Appendix F, Annual Probability of Exceedance for Australia. This defines importance levels, IL1 to IL4, based on the consequences of failure, and provides the annual probability of exceedance based on the structure's importance level and intended design life. Thanks for watching. Subscribe to Engineered 2025 for more.